Bismillahirrahmanirrahim. All right, now for example, you have a question 2x plus 3 less than equals to 5. Now, how would you solve this linear inequality?
You make x the subject.
As you make x the subject of the inequality. So it is going to be 2x less than 5 minus 3. That's going to be 2. So 2 over 2 is going to be 1. All right, if I try representing this on a number line, to say 0 is here, 1, and then minus 1. So it is going to be a hollow circle, and then all the numbers less than that. If I try representing the same information on a graph and grid, then first of all, I need to know the associated equation of this inequality, but I'm going to put it down here. So it's x equals 1. So the graph of x equals 1 is a vertical line passing through 1 on the x-axis. So for example, you've got 1 here. So in this case, the inequality is without the equal sign, so it is going to be a dotted line instead of a solid line. So this is how it is going to be, and as it is less than that, so I'll be shading on the left of this line. Okay, so there are two ways you can represent the inequality on the graph. Sorry, one way like this, and the other one is on number line. So our main focus is that how would we be representing an inequality on a graph, so that you can clearly see over here. So if you have an equality, this x is less than 1, so it means it's the shading, you're going to shade it on the left hand side. So on the left hand side of this dotted line, every point of x is less than 1. Okay?
Yes, sir.
All right. Now, regarding the solution of the inequality, now for example, you have the inequality as 5 minus 2x greater than 4. If I'm going to solve this one, it's same as before, but there's a little complication which you may come across while solving it. And here comes the rule of solving the inequality. Whenever you multiply or divide a negative number, okay, whenever you multiply or divide a negative number, the inequality changes. So for example, look at this question. So minus 2x greater than 4 minus 5 is going to be negative 1. So basically, in order to get rid of this negative 2, what I'll be technically doing is I'll be dividing it with minus 2 on both sides of the inequality. So as I have divided negative 2, in the next step, I'll be reversing the inequality, and I'll be left with just less than. So before it was greater than, now it's less than, and x is less than 1 by 2. Okay, got it?
Yes, sir.
Okay, now this was basics of linear inequalities. Now, now the next thing is um, just a quadratic inequality. Now, for that purpose, let's just see. Um, let's just look into a quadratic equation first. All right. Now, for example, you have a question: x squared minus 7x plus 10 less than 0. Okay. So I'm going to write down its associated equation first. So x squared minus 7x plus 10 equals to 0. Then I'm going to plot the graph of this. In order to do that, I'll be explaining you how to solve the inequality with the help of a graph, and then without the help of without the graph as well. Okay. So I'll be telling you the graphical meaning as well. So first of all, I'm going to factorize this and see the main information about the graph. So let's just check what the factors are going to be. So in this equation, it is x squared minus 5x minus 2x plus 10 equals 0. Okay?
Yes, sir.
And then you take x is common, x minus 5, minus 2 is common, then x minus 5 equals to 0. Then x minus 5 times x minus 2 equals to 0. All right, now just declare a misconception. Or what you can do is, instead of writing down the associated equation right at the beginning, what you can do is you can keep the inequality in all of these steps until you reach the factor part. So you can also do it like this. Now, the reason I'm introducing the associated equation over here is, okay, now if it was an equation, after that step, when you're solving the equation, you apply a zero product property and you say either x minus 5 equals to 0 or x minus 2 equals to 0, and from here you get the solution of the quadratic equation. But if you do the same here, x minus 5 less than 0 and x minus 2 less than 0, that would be wrong. Okay?
Yes, sir.
So there is a proper way to do that. Let's just look into that. So before we dive into a proper way, I'm going to draw how the graph of this is going to look like. So I'm just drawing the x-axis because that's what matters here. So after changing the sign of both of these, it's going to be plus 5 and this is going to be plus 2. So plus 2 on the left-hand side, plus 5 on the right-hand side. So this is how your graph is going to be. Okay, when you say that it is equal to 0 means y is 0. So y is 0 on the x-axis, which is basically a yellow line here. Then you tell the answer as the intersection points of the x-axis and the quadratic graph, and you say that the solution is 2 and 5. Got it? Is this point clear? That
Yes,
when
sir.
you say that it is exactly equals to 0 means y, you have placed the value of y as 0, and y is 0 on the x-axis, which is a yellow line here. Then you look for the intersection points of a yellow line and a graph of a quadratic, and wherever they intersect, that's basically the solution of a quadratic equation. So we say 5 and 2. All right, now in this case, we're not saying that it is equals to 0, we're saying it's less than 0. So y is less than 0 below the x-axis. Y is less than 0 below the x-axis. So below the x-axis, let's just draw a random line below the x-axis. So let's just say with a green color. So I'm going to make sure while drawing a line, I don't go beyond the turning point. Okay? So that this line beyond the turning point is of no use. So let's just say this is the line now. Now this green line is intersecting over here, isn't it?
Yes.
And one over here. If you look at this point carefully, this is closer to positive 2, but it's whatever this number is, it's greater than positive 2, isn't it?
Yes.
And also this one, it's closer to positive 5, but whatever it is less than positive 5. So one of the solution here is greater than positive 2, and the other one is less than positive 5. So let's just say we draw another green line here. Let's just this time I'm going to draw an orange line. So let's just say I've got another line, orange line, which is again less than 0, means it's below the x-axis. As you can clearly see that y is below the x-axis, this one, this orange line. Now this one is intersecting over here, and over here. Now, if you check whatever it is, whatever the solution is, it is greater than positive 2. And if you check from the other side, whatever the solution is, it is less than positive 5, isn't it?
Yes, sir.
All right. Now, basically, the solution lies between these 2 points. So whenever you are below the x-axis, means below the yellow line, no matter where you draw a horizontal line to represent y, means y is less than 0, means y is less than 0, means y is below the x-axis. So wherever you draw a line below the x-axis for this particular graph, you will see that it is going to intersect whatever values you come across. They are going to be between 2 and 5, isn't it?
Yes.
So I'm going to say that the solution for this one is going to be, I'm going to put x in the middle, um, like this. It's 2 and 5. That would be the solution. If you want to write it down separately, the way you write it down in the equation, then that's going to be x is greater than 2 and x is less than 5. You can clearly see whatever x is, it is greater than 2 and it is less than 5. But the better way is to write it down together in a combined manner. Alright?
Yes, sir.
Okay, now I'm going to take the very same example, but this time I'm going to change the inequality. So I'm going to copy this down. So I'm going to copy and put it here. And also I'm going to copy the graph of this one. Is it okay if I use the same example or should I take another one?
Either are fine, sir.
Right. Alright, so that's the graph of that one. So I'm going to erase everything below the x-axis because I'm not going to look into that now. So over here, let's just say this time the examiner says that find out the solution for the inequality x squared minus 7x plus 10 and it is greater than 0. So I'm going to take that down throughout the same way. Greater than 0, greater than 0, greater than 0, greater than 0. So exactly the same way, I am not allowed to do like this, x minus 5 is greater than 0 and x minus 2 is greater than 0. That would be completely wrong. So let's just see what we can do here. I'm going to explain it graphically first and then I'm going to help you write down the solution. So if you look carefully here, y is basically, that's y, it's greater than 0. This whole thing is y and it is greater than 0. So basically greater than 0 is above the x-axis. So this time I'm going to draw a line above the yellow line, saying like this. Okay? Now you can see that the graph is intersecting at this point, and whatever this point is, it is less than positive 2, isn't it? And whatever this
Yes, sir.
point is, it is greater than positive 5. Now I'm going to draw another line, so because y is greater than 0, so it's going to be anywhere above the x-axis. So let's just say this time I draw a line a little bit higher, just like this. Now I can clearly see that it is intersecting at this point. Then when I draw a line from here to the x-axis, I can clearly see whatever this point is, it is less than positive 2. And over here, it is greater than positive 5. Clear? So the
Yes,
solution
sir.
is basically that x is less than positive 2, and from this side of the graph I say that the x is greater than positive 5. So I can't combine both of these together because it's not somewhere in between. So the solution, there's a break here. There is no solution in between. The solution lies less than 2 and greater than 5. Okay, so I can't combine them together. So I'll leave it like this. The solution is x is less than 2 and x is greater than 5. So that would be your final answer. Both of these. Okay. Have you
Yes.
understood the association of the solution with the graph? Okay. All right. Now
Yes,
I'm
sir.
going to tell you the shortcut method. I will be applying that the same question. I'll be doing it. So x squared minus 7x plus 10 is greater than 0. I'll be doing the same question. X squared minus 7x plus 10 less than 0. Okay. Now, whenever you're doing this question, um, when it's greater than, I'm going to tell you a shortcut method where you don't need where you don't actually have to draw the graph. But just in case if the examiner suggests you, demands you the graphical illustration of the solution, then this is how you're going to do. But just in case if it doesn't, it's just to give you the question and ask you to give the solution, then this is how you'll be doing. So x squared minus 7x plus 10 is greater than 0. So over here, this is how I'm going to do. So x squared minus 5x minus 2x plus 10 greater than 0. X common, x minus 5 minus 2 common, x minus 5, and then greater than 0, x minus 5, and then x minus 2 greater than 0. So I'll come to the solution in a moment, but before that I'll be doing the same thing for the one which is less than 0. Okay, now for this one it is going to be x squared minus 5x minus 2x plus 10 less than 0. X squared, sorry, x is common, x minus 5 minus 2 is common, x minus 5 less than 0. X minus 5 is common, and then x minus 2 less than 0. All right, whenever the equation is then when it says greater than, your solution will be greater than the larger number and it will be smaller than the smaller number. So over here, so you write it down the associated equation, so which is going to be x minus 2 equals to 0. Now if you solve it, you're going to get positive 5 and positive 2. Now the solution is going to be greater than the larger number, which is this one, and the solution is going to be smaller than the smaller number. So x less than and x greater than. So as I said, the solution is going to be smaller than a smaller number. So I'm going to put 2 here. And it's going to be greater than a larger number. So I'm going to put 5 here. So that's a shortcut. This is how you can memorize. So you're going to do this whenever you have a greater than sign and the x squared is positive. Okay. Have you got it?
Yes, sir.
All right, I'm going to do, okay, now we'll be doing the same on the right hand side. Be writing it down, the associated equation for this inequality. All right, now the solution is going to be 5 and 2. All right, now whenever you have a case of less than, now in this case, the solution lies between the two roots. So whenever this is the case, you put the x in the middle and you put the smaller number on the left and the larger number on the right. So that you can say that x is between 2 and 5. Clear?
Yes, sir.
All right. It it goes opposite when the coefficient of x squared is negative. I'm telling you this just for the sake of information, but in the exam, this is how you'll be doing. You'll be always changing the coefficient to positive x squared. But just for the sake of knowledge, if you want to solve the inequality as is, like when by keeping the coefficient of x squared negative. So if this is negative and it's a case of greater than, then the solution is going to be smaller than the larger number. So then you apply the technique which you just applied over here on the right hand side. Then the solution will be between the two roots. Okay. And if the coefficient of x squared is negative and if it's less than, then the solution is going to be opposite, like means it is going to be smaller than a smaller number and it's going to be larger than a larger number. Okay. But in exam, that's just a cognitive load to memorize it separately for the negative coefficient of x squared. So all you have to do is to memorize with the positive coefficient of x squared. Is this clear?
Yes, sir.
All right. So should I give you a question to solve it?
Yes, sir.
All right. This was just a quadratic inequality on its own. All right. The next thing is going to be where you will be combining it together with the linear inequality. Before that, we'll be discussing the, what is it called? Before that, we'll be discussing the solution of the simultaneous equation graphically as well. All right. Now I would like you to solve this equation: 12 plus 4x greater than x squared. Solve this inequality, please.
Um, sir, do I dictate it or?
No, no, you do it yourself.
Okay.
You okay? You sound tired today.
Yes, sir. I'm okay.
Okay.
Sir, I'm done.
All right. Send it to me, please.
Okay.
squared plus 4x plus 12 greater than minus x squared plus 4x plus 12 greater than 0. You multiply it with minus 1. Alright, you forgot one thing, dear.
Yes, sir.
Alright, so basically, this is how you did. So you did minus x squared plus 4x plus 12 greater than 0, isn't it? And then you multiply the entire inequality with negative 1. That's what you did, isn't it?
Yes.
Alright, whenever you multiply or divide with a negative number, what happens to the inequality? It changes.
Right.
Okay, but just in case, if it was greater than, then whatever the roots are, for the greater than, your solution is right because it's you've done the solution the opposite way. When it's greater than, then the solution is smaller than a smaller number, is less than the smaller number, and is more than a larger number. Okay,
Yes.
but if it's less than, then it's between the two roots, the way you've written it down at the end. Okay,
Yes, sir.
so all you have to memorize is whenever the it's greater than, whenever you have greater than in the inequality with positive x squared. Okay, whenever you have a greater than sign, then the solution is greater than a larger number and less than smaller number. Okay,
Yes, sir.
and whenever you have a less than sign in the inequality, then the solution is between the two roots. Solution is between the two roots. Got it?
Yes, sir.
Alright, so for this one, the solution is going to be the two roots at the end. You get there are x equals -2 and x equals +6, and it's less than, so it is going to be between the two roots. So it is going to be x greater than -2 and less than +6. Clear?
Yes, sir.
Alright, so should we do one more question?
Yes, sir.
Alright. So 4x squared minus 3x minus 1 is less than 0. And then also do this one. X squared minus x minus 12 greater than 0. So one is the case of less than and one is the case of greater than. Okay?
Sir, so I solved this and I send you the picture.
Yeah.
Okay.
Or if you want to share the screen instead.
Alright, I can share my screen.
Alright.
How do I?
You will have an option like this. Do you see this thing?
Yes.
All right.
Sir, can you go back to the questions so that I can note them down first?
Okay.
Sir, can you see my screen?
Yep, I can. You're using notes.
Yes,
Why not good notes?
I don't know. It keeps crashing because of some iCloud issues, so I have to check that first and then
Okay, okay.
over. Sir, in the second one, I don't think it's possible to factorize it. So can we use the quadratic formula?
What is it? X squared minus x minus 12. You can factorize it, dear. So you need the two numbers whose product is negative 12x squared. And the difference of the two numbers should be negative 1.
Yes, so.
Isn't it 3x minus 4x?
Oh, yes. Got it. And then, sir.
Right, so it was a case of the first one was a case of less than, so it's between the two roots. The next one was a case of greater than, so it's less than the smaller number and more than a larger number. Great. So you should be able to memorize this, okay? So whenever you come across a question where the coefficient of x squared is negative, you multiply it with the negative 1 and make sure you reverse the inequality as well, okay?
Yes, sir.
All right. So I'm going to start sharing my screen again.
Okay, sir.
Okay, now let's just move on to the solution of the simultaneous equation and what does it mean what does it mean what does it have a graphical meaning? Okay, so I'm going
Yes,
to
sir.
put down give me a second. Okay, now for example I have a question: 2x minus y equals 6, 4x plus 3y equals to 2. Now, just for the quick recap purpose of solving simultaneous equation, you can solve them by substitution method and elimination method both. So I'm going to solve this by elimination method. In order to do that, let's just eliminate y. So in order to do that, I'll be multiplying equation 1 with 2 because in order to eliminate y, I need to have same coefficients and opposite sign. Sorry, I'll be multiplying it with 3 because the coefficient of y in the second equation is positive 3. Okay, so if I multiply 3 with the first equation, I'll have negative 3. So multiply equation 1 with 3. So that's going to give us 6x minus 3y equals to 18. And once I have that, so I'm going to add. So I'm going to tag this one as equation 3. Now I'm going to add equation 2 and 3 together. So equation 2 is 4x plus 3y equals 2. Equation 3 is 6x minus 3y equals 18. Upon adding them, I'm going to get 10x equals 20 and x is equals to 2. So once I have the value of x, I'm going to put this x in any of these equations in order to get the value of y. So let's just say I put x equals 2 in equation number 1. So x equals 2 in equation 1. So 2 times 2 minus y equals 6. So 4 minus 6 equals y, and y equals to negative 2. So this is the solution of this set of simultaneous equation. Now, what does this mean graphically? When you draw, now definitely this is a linear equation and this is a linear equation. Both of them, they are going to give you a straight line. For example, if you look at the first equation, so let's just say this is what you get. For example, from the first equation, so I'm going to tag this as line 1. And from the second equation, this is what you get. So I'm going to tag this as line 2. Now the intersection points of both, let's just say we have got y-axis over here and x-axis over here. So I've drawn the x's with the green. So the intersection point of the two lines, the x value is going to be 2 and the y value is going to be negative 2. This refers to the y value. Okay, so this was just a rough graph. Negative 2 is not above the x-axis. It was just to explain you that the intersection point, like x equals 2 and y equals negative 2, what does it mean? Clear? Hello? Maniza? Maniza, I can't hear you.
Now, sir, can you hear me?
Yep, I can hear you.
Sorry, sir, I got disconnected. I think there was some issue with the internet downstairs.
All right, no worries, no worries. All right, can you see the screen?
Yes, sir, I can see the screen.
All right, now, as you can see here that I've solved this pair of simultaneous equations by using elimination method. So I multiplied equation 1 with 3 first, so that I have same coefficient with the opposite sign, then I'll be eliminating a variable y. So when I multiplied equation 1 with the 3, this is what I got, 6x minus 3y equals to 18. So once I have the same coefficient, I'm going to add equation 2 and equation 3. Upon adding them, you can clearly see y got eliminated. This gives us 10x and this gives us 20, and from here x equals to 2. Now you can put x equals to 2 in any of these equations in order to get the value of y. I substituted x equals 2 in equation 1, and that gave me the value of y as negative 2. Now this is the solution of this pair of simultaneous equation where x is equals to 2 and y equals to negative 2. Now what does it mean? What does this thing has a graphical meaning when you draw? Now definitely both of these are linear equations, so both of them they are going to give you straight line. Now when you draw the graph of these, so for example, as you can see here, line 1 is for the equation 1, is just a rough line I'm drawing, it's not the accurate one. And line 2 is the line for the equation number 2, and let's just say the greens are the x's here, this one is the y-axis and this one is the x-axis. So the intersection point refers to the x value is this one and the y value is this one, so it's same as the solution. So solution is basically the intersection of the two lines. X shows the x value of the intersection point and y shows the y value of the intersection point. So I have drawn the graph on a graphing software for the both equations. So you can see the first equation, 2x minus y equals 6, and the second equation is 4x plus 3y equals to 2. Now, as you can see, the intersection point is this one, which is 2 minus 2. You can clearly see that it's 2 on the x-axis and negative 2 on the y-axis. And this is what we got after solving them algebraically. Okay?
Yes, sir.
All right. Now, this was solving a simultaneous equation, a linear, both linear. Now, I'll be doing where one of them is going to be a quadratic and the other one is going to be a linear. So, for example, one of the equations is x minus y equals 7, and the other equation is y squared plus xy plus 2x equals 5. So x minus y equals to 7, y squared plus xy plus 2x equals 5. Now one of them is quadratic and the other one is linear. Now I just tag this one as equation 1 and this one as equation 2. So I'll be solving this by substitution method. So let's just say I made x subject in the equation 1. So from equation 1, I get x equals to 7 plus y. So that's equation 3 now. Now I'm going to put equation 3 in equation 2. So put equation 3 in equation 2. Just a quick recap about this thing, about the substitution method. This equation came from equation 1. So you cannot substitute back into the parent equation, so you don't have an option. So that is why I have only one option to substitute in equation 2. So that's what I'm doing. So I'm going to put x as 7 plus y in equation 2. So it is going to give me y squared plus, okay, for x, I'm going to write down 7 plus y plus 2, another x, I'm going to put 7 plus y one more time, and there you go. Now I'm going to simplify this equation, give it a shape, and see what do we get. So 7y plus y squared plus 14 plus 2y equals 5. So 2y squared, 7y and 2y is 9y, and 14 take away 5 is 9 equals 0. So this is the quadratic equation I came up with. So I'm going to solve this by a quadratic formula. So x equals minus b plus minus b squared minus 4ac, and then whole divided by 2a. So next I'm going to use calculator to reach to the answer directly. 299, and one of the answer for, okay, so sorry, I put x here, it was y, because this is the equation in y. I made a mistake by putting x equals to. Okay, so this is y equals to. So one of the solution is -3, and the other solution is -1.5. So these are the two solutions for this quadratic equation. So this is two values of y. This is one thing I've got as of here. So as you remember, it was a simultaneous equation, means there were two variables, x and y. So I've got two values of y. For both of these, I'm going to find out the value of x. So first of all, I'm going to put y equals -3 in equation 1. So that's going to give me x plus 3 equals 7. So put y equals -3 in equation 1. Just x minus 7 equals 7. That was equation 1, so I'm going to put that here. X minus y equals 7. Okay, so x minus 3 equals 7. So x plus 3 equals 7. So x equals 4. So that's one pair of the solution, that when x is 4, y is -3. Okay, so that's one solution. And another one is, I'm going to put y equals -1.5 in the same equation. So x minus 1.5 equals 7, x plus 1.5 equals 7, and x equals 7 minus 1.5, which is 5.5. So when x is 5.5, y is -1.5. So that's another solution. So we've got four solutions here, two values of x and two values of y. But when x is 4, y is -3, because I got 4 when I plugged in 3 into the equation, so that comes together. And when I plugged in -1.5, I got 5.5, so this solution comes together. So this is now the graphical meaning is for a quadratic equation. Let me just draw a rough graph here, like, okay, just like this one. And the another equation was a linear one. Let me just draw another linear graph like this. Now you see that there are two intersection points. So let me just draw the x-axis and the y-axis. Now one of the solution is one value of x, and for this value of x we've got one value of y, and for another value of x we've got another value of y from the second intersection. Now just to verify this and to show you the exact values, just to support the answer, I'm going to draw the graph of both of these on a graphing software. So one of the equation is x minus y equals 7, and the other equation is y squared plus xy plus 2x equals 5. So let's just do it. So I'm going to erase this. So one of the equation was x minus y equals 7. All right, and the another equation was y squared plus xy plus 2x equals 5. All right, now it doesn't look quadratic because we've got y squared and then xy, and two variable quadratic. That is why we've got a very strange graph. The thing is, the second degree equations, we're having two solutions, two values of y. So but these, so you have two intersection points. One is 4 minus 3, as you can see here, 4 minus 3, and the other one is 5.5 and negative 1.5. There you go. Clear?
Yes, sir.
All right. So this is what it means by solving these two together. All right. Now, if you recall from a solution of just a quadratic equation, just a recap, because there's something associated with that now. If you recall from just a solution of a quadratic equation, if you have an equation like ax squared plus bx plus c equals 0. Now, if you are basically, if you want to know what type of roots does it have, uh, if b squared minus 4ac, which was basically a discriminant, if it was greater than 0, then you had real and distinct roots. Remember? And if b squared minus 4ac was exactly equals to 0, then you had real and repeated values of x. And if you had b squared minus 4ac less than 0, means you had complex roots. If you recall the graphical meaning of of all three of these, for the first one, if this is the x-axis, the graph is going to cut through the x-axis at two different points. And when it is exactly equals to 0, the graph is going to be tangent at one point on the x-axis. And when in the case of the last situation where it's less than 0, it is not going to touch or intersect the x-axis at all. Okay?
Yes, sir.
All right, now I'm going to go. So this was just a recap of quadratic equation where you have y equals to ax squared plus bx plus c, and then you put y as 0, and this is what you get, and then you solve y. Putting y as 0 means you're finding the solution on the x-axis. Now, if you combine a quadratic and a linear equation together, let me just give you an example here. Now, for example, you have a quadratic equation as y equals 6x squared plus 3x minus 7. That's a quadratic, so it is going to have a specific graph. And you have a linear equation y equals to 2x plus 8. Now, if I put y equals 0 in this one, so that would be purely the solution of this quadratic equation, okay? But if I say as both of them they are equals to y, if I combine them together, because just by following this property that if a is b and a is also equals to c, then I can say that b is equals to c. We're going to do the same. Y equals to this, y is also equals to c. This means both of these they are equal as well. So 6x squared plus 3x minus 7 equals 2x plus 8. Now, you know that you have merged together a quadratic and linear. Okay. Now,
Yes,
if you
sir.
simplify this, upon simplifying, although you will get a normal quadratic equation in the form of ax squared plus bx plus c, but you know the history of this, that from where you got this, don't you? So you know its history that it actually came from merging quadratic and linear together. Okay. So when you solve this, you'll be actually solving the quadratic and linear equation simultaneously. Solution of this does not mean the intersection of quadratic on the x-axis. Solution of this actually means, because you know the history of it, if you don't know the history of it, for example, you don't know this part, just imagine this part does not exist. If you get just this equation, the solution of it means the intersection of quadratics on the x-axis, okay? But now in this case, you know the history of this equation, that it came from combining together these two things. Now the solution of this is going to be the intersection of linear and quadratic, okay?
Yes, sir.
All right, now when you solve, okay, now I have reduced both of these into this form. Now you apply the same discriminant concepts here. If b squared minus 4ac is greater than 0, then it means that linear line, the linear graph will intersect the quadratic graph at 2 points, just like this one. It had distinct solution, means two solutions. Okay, so the meaning is that linear graph will intersect quadratic at 2 points. Just give me a minute, please. हेलो अस्सलाम वालेकुम वालेकुम सलाम आज ही ऊपर आ जाओ मेरी क्लास लगी हुई है आप आज ठीक है okay b squared minus 4ac if it is exactly equals to 0 then just like this one when it was exactly equals to 0 it was real and repeated and if you look at the graph it was just tangent so it was just one solution so the same thing applies here means the linear graph will be tangent to quadratic. Okay, and then if b squared at the end, if b squared minus 4ac is less than 0, then it means that linear graph will not intersect quadratic, will not wait a minute, linear graph will neither intersect nor will be tangent to quadratic. Let me show you the graphs of these, the rough idea. So for example, that's the quadratic, and then this is how the linear is going to be. So it will be cutting the quadratic at 2 points, okay?
Yes, sir.
In the case of second example, if that's the quadratic, the graph will be just touching the quadratic, like tangent at it. In the example of the last one, if that's the quadratic, the graph won't be intersecting or touching the quadratic graph. Okay? When you
Yes,
draw
sir.
the graph of this one, that will definitely show the intersection on the x-axis because this equation is not same as this one. This yellow graph refers to this one. This white graph refers to this one. But we are getting this information from the discriminant of this, where we have a new equation after combining these two together. Okay? Just remember this. Now I'm going to show you this whole thing on a graph. Now, for example, let's just say, okay, now the first equation is 6x squared plus 3x minus 7. So 6x squared plus 3x minus 7. Okay, so I forgot to put y equals I equals. There you go. So that's a quadratic equation for this one. Quadratic graph for this one, okay? 6x squared plus 3x minus 7. Now, as you can clearly see, when I haven't actually solved this question yet, but if I just quickly solve this question on the calculator, let's just see what do we actually get. So 6, 1 minus 15, and I'm getting distinct roots. So basically, this is what I'm going to obtain from this and this equation, okay? You won't be applying this test on the original quadratic because you don't know what is going to happen when you combine it with the linear. I'm actually checking the relation of a linear and quadratic. For that, you need to combine them together and reduce it to the new quadratic. Once you have that, then you apply a discriminant test. Okay?
Yes.
All right, now the next is 2x plus 8. So y equals 2x plus 8. Now you can clearly see that the graph is intersecting at two different points, over here and over here. I would like you to note down these points, please. One is 1.5 and 11. All right, I'm going to put it down here. So the intersection, wait a minute, I'm just going to go and check it though. All right, so what was I doing? Yes, I was noting down the intersection points of, okay, so one of the point is 1.5 and 11. So basically it's 1.5 and 11, and the other one is negative 1.6 and 4.6. The other one is negative 1.6 and 4.6. So if you solve them algebraically, both of them simultaneously, so this is what you're going to get: two values of x and two values of y. So on the graph, this is the intersection. Now, what does this equation actually mean? If I draw the graph of this one separately, now let's just see what does happen there. So 6x squared plus x minus 15. So 6x squared plus x minus 15. X minus 15 equals 0. That's the green graph. Okay, wait a minute. So I think I shouldn't be putting 0 here. Support. Okay, yeah, that's the green graph here. Now, if you look here, what is the value of x? Hello?
Sorry, I was speaking, but I didn't realize I was muted. 1.5.
1.5. And what is the value of x on the other hand? Negative 1.6. See? So this gives you, this is basically a reduced form of S1. This gives you the x values, both of these, on the x-axis, because over here you have y as 0. Okay?
Yes, sir.
So now I'm going to repeat the concepts here. So solving the quadratic and linear together means looking for the intersection of a quadratic and linear graph. That's a very simple concept. Now you can solve them simultaneously the way we've done up here. Okay, so we have also, I've started a process of solving simultaneously till here. I stopped here. If you continue, you will get the values of x, the two values of x from this equation. Once you have the two values, put in here one by one, and you will have two respective values of y. All right. Now, the main thing I wanted to explain here was the discriminant concept. Due to it, I stopped here. If you are able to reduce the two equations, one quadratic and one linear, as a new quadratic in the form ax squared plus bx plus c equals to 0, then you can actually check that what the solution of the two equations are going to be like. And if you can have two solutions, you can have one solution, and you can have no solution at all. And this is how the graph is going to look like. Got it?
Yes, sir.
All right, now I'm going to combine this concept with the inequality now. Should we do it?
Yes, sir.
All right. So I'm going to look for a question where, okay, now here's a question where the examiner is asking you to solve 12 plus 4x greater than x squared. Okay, so in the first part, this is what you need to solve. And then also, okay, now this and 5x minus 3 greater than 2. So we need to solve both of these simultaneously. Hello, Sam? चल रही है अभी ला okay. All right, so I'm going to solve both of them separately. So let's just begin with the linear one because that's the piece of cake. So 5x minus 3 greater than 2, 5x greater than 5, and x greater than 1. Got it?
Yes, sir.
All right, now I'm going to move on to the quadratic one. This is the same as the one I gave you earlier. So I can leave 0 on the left-hand side and move everything on the right. That's another way to do it. X squared minus 4x minus 12. And then now I can see 0 is greater than all of this. So this is going to be less than 0. So x squared minus 4x minus 12 less than 0. And upon, now I'm going to factorize it. X squared plus minus 6x plus 2x minus 12 less than 0. X is common, x minus 6 plus 2 is common, x minus 6. X minus 6 is common, and then x plus 2. And I'm going to write down the associated equation for both of them. And the solution is 6 and minus 2. Now this was a case of less than, so the solution is going to be between the two roots. So I'm going to put x in the middle, and the solution is going to be x is greater than negative 2 and less than 6. All right, now I'm going to combine the two solutions together. And in order to do that, I'm going to take a help of a number line. So let's just draw a number line here. Okay, now 0 minus 1 minus 2. 1, 2, 3, 4, 5, 6. All right, so for this one, I'm going to be using a yellow pen. So x is greater than 1. Okay, for this one, I'll be using an orange pen. So x is greater than negative 2 and it is less than 6. Upon combining both of them together, I need to make sure that both of them, they are satisfied. So what do you think? What would be the solution? What would be the final answer in this case? This one is saying x should be greater than 1. This is saying x is greater than negative 2 and less than 6. Now I need to combine the two solutions together. Hmm? Can you look for the common area of both?
Yes. From 1 to 6.
That's it. Okay, so basically x is less than 6 and greater than 1. So that would be your final answer for this one. Got it?
Yes, sir.
So this is the solution of a quadratic and a linear inequality together. So today we learned a lot of things. First of all, what do we actually mean by solving the two simultaneous equations together, both linear, both quadratic, their graphical meaning. And then we learned a quadratic inequality, and then we learned a linear inequality, and then the combined solution together. Okay?
Yes, sir.
So this was one whole chapter. Would you be able to practice? Would you be? Do you have enough time to practice these?
Um,
In the next
yes,
time,
sir.
in the next lesson, what we can do is we can pick random questions from the same chapter and practice it. If you want, I can proceed further. If you want, we can practice questions from the same chapter.
I do want to practice a few questions from this because the discriminant part is kind of like confusing. So I want to get like more practice with it.
This one?
Yes, like
Ah,
applying this.
applying this thing. Okay, fine. This just gives you information about what type of solution would you get when you solve a linear and a quadratic together. But you can't get
Okay.
to, you can't apply this directly to the quadratic of the given equation. You need to merge these two together and get to this new quadratic. Once you have the new quadratic, then you apply the discriminant test. If it's greater than zero, then it means you will have two solutions. It means graphical illustration shows that the line will be intersecting the quadratic at 2 points. If it's exactly equals to zero, then it means that the line will be the linear graph, this linear graph will be tangent to this quadratic. I mean, it is going to just have one solution. And if it is less than zero, means this linear graph will not even touch or cross this quadratic. So it will be going away from far apart. So this is what it means. Well, don't worry, we'll be practicing it even more. Okay?
Yes, sir.
Chalo. ठीक हो गया. Any questions you would like to ask?
No, sir. No questions.
चलो ठीक हो गया. I'll be sharing the notes with you on your WhatsApp.
Okay, sir. Thank you.
Welcome. Take good care of yourself. Allah
You too,
Hafiz.
sir. Allah Hafiz.